Dear students, today in this module we will be discussing about solid waste disposal sanitary landfilling part 2. In the previous module under sanitary landfilling part 1, we discussed about what is waste disposal, what is the significance of disposing the waste in a controlled or safe condition. Then we discussed about the uncontrolled dumping and what are the problems associated with uncontrolled dumping. Then we talked about or defined what is controlled dumping or a landfill. Landfill is an engineered structure for the safe containment of waste. Then we also discussed about what are the components of landfill and what are the different types of landfill. Now, in this module, we will be discussing in detail about the structure of landfill. Each component will be discussed in detail. Then we will also look into what are how the waste is degraded inside the landfill. With this introduction, let us get into the learning objectives of this module. The learning objectives of this module include 1. To understand the structure of a landfill, 2. To define what are the types of lining material that are used for construction of a landfill. Then we will also discuss about the different liner systems that are available that becomes a component of a landfill. Then we will discuss about the waste emplacement, that is how the waste is loaded in a systematic manner. Then we will finally discuss about the structure of the landfill cap or cover. Then, as I told you, we will discuss how the waste gets degraded within the landfill. Finally, we will also briefly study about certain factors that influence waste degradation within a landfill. Now, you all know waste disposal, it is generally done in an open area in underdeveloped and developing countries. Now, in a developed country, they follow a controlled or safe manner of waste disposal through a practice of landfilling. Now, landfills are nothing but engineered structure where your waste is stored and they are contained in a safe manner, and this protects the different environmental matrices from being polluted, and also it protects the human beings and animals from various health hazards. Now, controlled dumping or landfilling, it is considered as one of the largest route of disposal, and it is considered as one of the safe method of waste disposal. Now, landfills are designed and operated according to the acceptable standards that are designed in a way to protect the environment and the health of the people. Now, landfills are not homogeneous, they are usually made up of cells. As I mentioned earlier, here the waste is loaded in a systematic manner. So, it is not like haphazardly placed or it is not homogeneous. So, here the waste is placed in cells where a discrete volume of waste is kept isolated from the adjacent waste cells by a suitable barrier. Now, the particular option of waste disposal is suitable only when the land is available at an affordable price, you have adequate workforce and technical resources. If these three things are available, then you can set up or you can go for a landfill option. Now, in the previous module also we discussed what are the three different types of landfill. So, again just browse through them. What are the different types of landfills? Landfills are of three types. One is your sanitary landfill or specifically for non-hazardous waste. Second is your secured landfill or the landfills specifically designated for the hazardous waste, and third one are landfills which are designated for the inert waste. Now, hazardous waste, again they have four major characteristics, either all or either one of these characteristics, then they are categorized as hazardous. Corrosivity, reactivity, ignitability and toxicity are those characteristics. And non-hazardous waste includes your municipal solid waste, any waste which is categorized under non-hazardous category. Now, inert waste examples can be glass, bricks, your construction and demolition waste all comes under your inert waste, and generally they do not show any reactivity. So, this landfill where inert materials are stored are called as inert landfills or waste landfills for inert material. Now, components of a landfill. There are three major components of a landfill. One is your liner system which is placed at the bottom and sides. Second one is waste emplacement, where we will be discussing about what are the different ways by which the waste are placed or arranged in a systematic manner within the landfill area. Then we will discuss about the landfill cover, which is the last component and it occupies the topmost layer of your landfill. Now, this is how a landfill actually looks like. You can see how in an area the soil is trenched out and then lined with the liner material at the bottom, and then the waste is loaded in a systematic manner or in discrete cells. In one cell it will cover every day's waste collection. So, old cells are those which are deposited before certain period, and the new cells will be in recent times. You can see how a truck comes and dumps its waste, and then cell by cell the waste is dumped or loaded. On the right side and left side you can see groundwater and landfill gas monitoring stations, and these are specially for post closure monitoring. When the groundwater monitoring wells are used for collection of water samples from the groundwater table and then analyze the water quality. If by doing so you can find out if there is any rupture in your liner system and there is any leakage of leachate into the groundwater body. Likewise, the landfill gas monitoring station will assess the emission of gases that occurs within the landfill. So, especially the landfill gas monitoring and groundwater monitoring is done at the post closure monitoring. Now, let us discuss about the landfill design and engineering. In a previous module, we discussed about various considerations that are required for designing a landfill. Now, what is important in a landfill is the geological barrier or the liner system that is generally provided at the bottom, sides and at the top. So, the main purpose of a landfill is to contain the waste and protect the environment through a biological barrier and liner system at the base, sides and on top, which is generally called as a landfill cap or cover. Now, the type and requirement of a barrier system generally depends upon the nature of waste that is deposited onto the landfill site. For example, inert waste does not require much protection, unlike your municipal solid waste and your hazardous waste. When you compare the municipal solid waste and hazardous waste, for hazardous waste you have to provide more protection when compared to the municipal solid waste. More protection means the hazardous waste require more protection because a small or slight leakage of leachate from the hazardous waste can cause serious and dangerous hazard to the environment as well as to the health of an individual. Now, the barrier system should prevent the pollution of soil, groundwater or surface water and ensure efficient collection of leachate. The geological barrier required for containment is determined by the geological and hydrogeological conditions below the landfill and near the vicinity of the landfill site. Now, the characteristic of geological barrier may be achieved by the use of either natural as well as synthetic materials. Now, let us discuss about the liner system. Now, a landfill liner is nothing but a barrier that is laid at the bottom as well as on the sides of the landfill to protect the contaminants from entering into the soil and groundwater. The landfill liner system are also designed to control the accumulation and migration of landfill gas. The liner system can be made of both natural as well as artificial or synthetic materials. A liner system is generally a combination of many layers and it consists of a natural liner, a synthetic liner, a leachate collection system and a geofabric for preventing the solid material entry into the leachate collection tube. These become the component of a liner system. Liner is not a single layer, it is a combination of many layers. The liner materials should have less permeability so that it should avoid the percolation of the watery material that oozes out from the waste material during degradation. Now, the permeability or hydraulic conductivity of the materials are calculated before installing or using them in a liner system. Now, they are generally calculated based on the Darcy's law, which describes the flow of a liquid through a porous material. Now, the ease at which the leachate flows through the liner material is called as the hydraulic conductivity. The hydraulic conductivity of few materials are listed in the table. Now, let us see what are the different hydraulic conductivity of different materials that are used in the liner system. Now, the well graded sand gravel mixture contains or consists of an hydraulic conductivity or permeability of 2 into 10 to the power of 4. Likewise, your clean sand or gravel sand contains 5 into 10 to the power of minus 4. Silty sand again 5 into 10 to the power of minus 5 meter per second, and compacted clay contains a permeability of 1 into 10 to the power of minus 8 to 10 to the power of minus 10 meter per second. And bentonite, geosynthetic clay liner, geotextile, geonet, they all possess a permeability or hydraulic conductivity of 5 into 10 to the power of minus 5, 1 into 10 to the power of minus 10 to 10 to the power of minus 12, 1 into 10 to the power of minus 4 and 1 into 10 to the power of minus 1 meter per second respectively. Now, let us see what are the hydraulic conductivity requirement for 3 different types of landfills which we discussed earlier, like your secure landfill and your sanitary landfill and landfill for your inert material. For hazardous waste landfill, the hydraulic conductivity should be around 1 into 10 to the power of minus 9 meter per second, and the liner material thickness should be of 5 meter. For non-hazardous waste landfills, the hydraulic conductivity should be 1 into 10 to the power of minus 9 meter per second, and the thickness of liner material should be 1 meter. For inert waste, the hydraulic conductivity should be around 1 into 10 to the power of minus 7 meter per second, and the landfill liner material thickness should be 1 meter. Now, from this you can see the hazardous landfill, the liner materials are more thick when compared to the other 2 landfill systems. Now, let us discuss now about the different liner materials that are used for constructing a liner system and what are the significant features, why they are actually used as a liner material. A large variety of natural, synthetic mineral material and synthetic polymeric materials are used for the construction of hazardous, non-hazardous and inert waste landfill sites. The choice of liner material and barrier will depend on the type of waste, geological and hydrological condition in the surrounding environment, the property of derived leachate and the resistance of the liner to the leachate, because leachate has a lot of materials which has rupturing potential or a corrosion potential which will react with the liner material and it will break them or weaken them. So, these parameters should be considered before you select the material for construction of a liner system. Now, first let us discuss about natural clay. Now, clay is an unconsolidated rock composed of clay minerals. They are formed as a breakdown product from weathering of pre-existing rocks. Clay contains minerals like montmorillonite, illite and kaolinite, and they are of extremely fine grain size. Fine grain size means the porosity is extremely low and permeability also is very low. The clay liner consists of a mixture of clay minerals and fine silt particles which blend to form a clay or clay soil with suitable permeability. The clay material can be excavated from the site where the landfill construction is proposed. So, if clay is available, then you can take it from the source, or if it is not available, you can collect it from the adjoining areas. Now, once you collect the waste, you can trench out the clay that is present in the landfill site, then take it out and mix it to a homogeneous mixture. It is also necessary for you to sieve the clay materials that are excavated from the site. This will ensure the removal of large or small rocks which are present in the clay mixture. The clay will then be transported and spread onto the landfill site through a bulldozer or scrapers at that site. Once they are spread onto the site, then they will be compacted by using large roller vehicles so that it forms a homogeneous layer by breaking up large pieces of clay. This will also reduce the void space between the clay particles and also serve to increase the density of the layer. Now, you also can use bentonite enhanced soil. Bentonite is a mixture of clay minerals, especially montmorillonite type. Now, you also have sodium bentonite and calcium bentonite type. Sodium form possess lower permeability, whereas the naturally occurring clay does not have a high enough level of clay mineral to produce suitable low permeability. Bentonite clay is added to form bentonite enhanced soil. Now, the bentonite type clay minerals have a high swelling characteristics on absorbing moisture. In general, if you see, the clay, though it has higher porosity, when it comes in contact with soil, they start absorbing water. Once it absorbs water, it swells and it locks the interstitial spaces. As a result, it will not allow water to percolate through them. This is a characteristic why clay is preferred as a material in liner system. Now, the bentonite enhanced soil further swells under pressure and results in lower permeability. Pressure, how does the pressure actually occur is like the pressure that is created by the overlying waste, as well as when the vehicles start moving over this mixture, further pressure is added and as a result they swell and then they decrease the permeability of the material. For sodium bentonite clay liner, 5 to 15% of sodium bentonite is added to the original soil, mixed and then it is used. The next type of liner material that is used is geosynthetic clay liner. Now, geosynthetic clay liner is again a mixture of bentonite clay which is mechanically or chemically adhered means or fixed to a geotextile fabric. Now, the bentonite layer may be sandwiched between two layers of geotextile fabric, where the layers are again joined by adhesives or by needle punching or by stitching. Now, the geosynthetic clay liners are approximately 1 centimeter thick. The geosynthetic clay liner rolls are laid over the natural clay soil or polymeric flexible membranes and joined by bentonite cement. These liners are often used as alternatives to natural compacted clay liners. The next type of liner material is your flexible membrane. Flexible membranes are synthetic polymeric plastic materials that have extremely low permeability. High density polyethylene and PVC are commonly used for fabrication of these flexible membranes. Now, the thickness generally varies between 0.75 to 3 mm. Now, the properties that determine the suitability of these liner materials include 1. Density, 2. Tensile strength, 3. Puncture resistance, 4. Tear resistance, 5. Resistance to UV and ozone, and finally chemical resistant. Membrane chemical resistant is very important since the leachate may contain a range of organic and inorganic acids and alkalis and organic hydrocarbons. They tend to react with these membranes and as a result they corrode or puncture the membrane, which may the leachate into the through soil, it may enter into the groundwater. Now, in this table you can see the different types of polymers that are used for preparation of your flexible membranes. On one side you can see thermoplastic, the other one thermoset, and they are also used in combination. Thermoplastic PVC, LDPE, HDPE, I mean low density polyethylene, high density polyethylene, then CPE, I mean chlorinated polyethylene, elasticide polyolefin and ethylene interpolymer alloy and polyamide. All these things are used for the preparation of flexible membrane. Likewise, under thermoset polymers you have butyl or isoprene isobutylene, ethylene or polypropylene diene monomer, polychloroprene polypropylene and ethylene vinyl acetate. In combination you have PVC along with nitrile rubber, PVC with ethyl vinyl acetate, cross linked CPE, chlorosulfonated polyethylene and hypolon. So, these are the different types of materials that are used for manufacturing or fabrication of your synthetic flexible membranes. Another type of liner material that is popularly used is geotextile. These fabric materials are polymeric plastic membranes that are used as filtration material to filter out fine grained particles from the leachate that enters into the drainage layer, so that the leachate system or the leachate collection tube that is installed does not get blocked. Now, geotextiles are composed of polypropylene or polyester fibers which are manufactured to form a fabric type material. Geotextiles are generally not preferred or not used for containment, they are just used for filtering out larger particles because they have relatively higher permeability when compared to other liner material. Now, let us discuss about the different liner system. Now, as I told you, liner system is not just one layer of liner material, it is a combination of layer where you have a natural liner, a synthetic liner, a leachate collection system and also a geofabric. Now, the liner system are classified into three main types. One is your single liner system, the other one is your composite liner system and the third one is your double liner system. Now, the type of liner system is selected or decided based on the nature and composition of waste, cost, geology and hydrogeology of the surrounding area. Plus, they should not allow the groundwater to seep into the landfill. Also, they should protect the escape of leachate and gas from the landfill. Other characteristics which are important is like they should be resistant to chemical reaction, they should have proper stability and good lifetime. Now, let us discuss about each of them in detail. The single liner system are preferred for low risk waste. They are used in places where the chances of leachate escaping is very negligible. It comprises of a primary barrier which consists of clay and bentonite enhanced soil. Now, above and below the primary layer would be the protection layer which is made up of geotextile, and geotextile filters out the suspended solids. Now, between the waste and the protection layer would be the leachate collection system which consists of a drainage pipe. Beneath the liner system there can be a groundwater collection system which consists of gravel covered by geonet. The groundwater collection system is not a compulsory option in the liner system. Now, this image of a single liner system, you can see on top you have waste, below that you have the liner system. Just below the waste you have a leachate collection system which is having or which is lined with a geotextile for filtering out any solid particles that enters through the leachate into the leachate collection system. Now, below the leachate collection system you have a primary barrier, and this primary barrier is lined on either side with a protection layer, and below that you have a groundwater collection system. As I told you, groundwater collection system is not a compulsory option in any liner system. Now, the primary barrier can be clay, on either side you can have bentonite enhanced soil or any other geomembrane or any synthetic membrane, you can have it on either side. The second type of liner system is your composite liner system. Here two different types of liner material are generally used, one your clay based mineral layer and the other one is polymeric membrane layer. Now, this provides more secure containment of waste when compared to a single liner system. Now, the primary barrier that is used here is a synthetic polymeric flexible membrane with a separation layer of thin geotextile or a polymeric material. The polymeric material can be HDPE, LDPE or PVC. The secondary barrier can be a clay, bentonite enhanced soil or geosynthetic clay. Now, between the waste and the protection layer would be the leachate collection system which consists of drainage pipe. Beneath the secondary barrier again you have a groundwater collection system which consists of gravel covered by a geonet. Now, as I told you, in this figure you can see below the waste, again similar to your single liner system, you have a leachate collection system which is lined with a geotextile. Then you have a primary barrier and a secondary barrier. Primary barrier, it is a synthetic flexible membrane which can be LDPE, HDPE, PVC etc., and secondary barrier is your clay. The primary barrier and secondary barrier on either side is again protected by a separation layer, and below this you have a groundwater collection system which generally consists of gravel lined with geonet. The third type of liner system is a double liner system. Again, this is for more secured protection and this is especially used for your hazardous waste. Here the primary barrier is a synthetic polymeric flexible membrane which is separated by a thin layer of geotextile or a polymeric material. The polymeric material, as I told you earlier, it can be HDPE, LDPE and PVC. The secondary barrier is clay, bentonite soil or geosynthetic clay. Now, between the waste and the protection layer would be the leachate collection system which consists of a drainage pipe. Beneath your secondary barrier there can be a groundwater collection system which again consists of gravel covered by a geonet. An intermediate layer with high permeability drainage layer is incorporated between the primary and the secondary barrier. This layer is for the collection of landfill leachate and gas. A separation layer again made of geotextile fabric is required between each barrier. Now, let us discuss about the waste emplacement, which becomes the second component in the structure of a landfill. Now, waste emplacement is nothing but how the waste is loaded in a landfill in a systematic manner. As I told you earlier, the loading of waste in landfill is not homogeneous. They are done in a systematic way in cells where discrete amount of waste is kept isolated from the waste cells by a suitable barrier. There are different methods of waste loading in a landfill. The first one is a trench method. The trench method involves excavation of a trench into which the waste is deposited and the excavated material can be then used as a cover. The second method is an area method where the waste is deposited in layers. For example, here the entire landfill area, the waste that is collected is brought and one uniform layer is made on the landfill area. Once one layer is completed and the next part of waste again will be dumped and covered in an entire area to form the second layer. So, here if you have a cross section, you can see the waste dumped or deposited layer by layer. It also looks like a terrace. Now, the major disadvantage of this type of method is that during this process the leachate generation is more and it is very difficult to control this leachate generation. The next type of method is cell method. This is most popularly used method and it involves the deposition of waste within a pre-constructed bounded area. And these cells are imaginary, you cannot see just small cells there, these are imaginary cells which you create. They are generally preferred method in a industrialized world. As I told you earlier, it is one of the preferred method for the industrialized world, I mean the developed countries, because they encourage the concept of progressive filling and restoration. Now, when you do a cell method, the deposition of waste or the loading of waste is done in a tidy manner and they serve both to conceal the tipping operation and trap much of the litter that has been generated. So, out of the different methods, cell method is more preferred method. Now, here the everyday waste after being dumped in the landfill cell, it will be covered with one layer of soil. This will prevent the wind blown litter. In the previous module also we discussed about this. After every day when the waste is loaded onto the landfill, you have to cover them with one layer of soil. Now, by doing so, what happens is it will avoid the wind blown litter. Here you can use one layer of soil. If the soil is not available, then you can use alternate materials like green waste or other refuse materials instead of soil. Now, when you add soil, the microorganisms present in the soil can act like an inoculum for waste degradation. Now, the third component of the landfill system is your landfill cover. Now, the landfill cover is also called as landfill cap. Now, this is the final layer or the topmost layer of a landfill, and the purpose of this landfill cap is to protect the waste from the entry of water and surface runoff into the waste. Also, it will prevent or control the release of landfill gas and prevent ingress of air, which would disturb the anaerobic degradation process which occurs inside the landfill. The final cover can be landscaped with soil so that you can enable them to have plant growth. Now, the design of landfill cover again depends upon the waste material. Now, the structure of a landfill cover or cap, if you see, this is above the waste layer. Now, overlying the waste, it will be your gas collection layer. Now, this gas collection layer is a porous layer which is composed of a geonet or geotextile or coarse sand, and this is used for the permeation of gas from the waste through this into the gas collection system. Now, above this is a barrier layer which is made up of plastic geomembrane, geosynthetic clay liner of bentonite and geotextile or natural compacted clay. Now, this layer will again protect the ingress of air or the entry of air and water into the mixture. Now, above this layer is a drainage layer which is used to collect water during precipitation or rainfall. Now, above this is a protection layer to prevent the burrowing animals, the entry of roots and man-made intrusions into the landfill. Finally, on top is a layer of topsoil which is generally laid for facilitating or enabling growth of small rooted plants, just for the landscaping or beautification purpose of the landfill. Now, let us discuss about the waste degradation that occurs within the landfill. You all know within a landfill, after the waste is being loaded, you have certain physical, chemical and biological reactions that takes place in the waste matrix or waste material. Now, the physical and chemical reactions, physical reaction will be just simple compression, settling, compaction and so on. The chemical reactions can be certain precipitation, redox reactions, oxidations that occur within the waste pile. Majority, if you see, the waste undergoes a biological degradation with the help of microorganisms, and this occurs in various phases. When the waste is loaded, it contains a lot of oxygen in them. When oxygen is present, it undergoes aerobic degradation. Under aerobic degradation, the waste degradation is much faster and results in the production of CO2 and H2O. And once after this stage or the aerobic stage exists only for few days, maybe maximum to 5 days. After that, slowly the oxygen that is present in the waste will be used by the microorganisms, and slowly the aerobic bacteria will be replaced by your anaerobic one. So, from the stage 2, it is the anaerobic degradation of waste that takes place within the waste pile. Now, the anaerobic degradation again takes place in 3 different phases. One is your hydrolysis and fermentation, the second one is acetogenesis and third one is methanogenesis. Now, in hydrolysis and fermentation, the waste undergoes anaerobic degradation and results in the formation of organic acids and ammoniacal nitrogen. Organic acids and ammoniacal nitrogen is produced. Now, this again at the end of hydrolysis or fermentation phase, your acetoclastic bacteria starts growing, and this shows the beginning of your acetogenic phase. In the acetogenic phase, what happens is your organic acids are converted into acetic acids, hydrogen and carbon dioxide. Now, at the end of acetogenic phase, your acetoclastic bacteria will be replaced by your methanogenic bacteria, and the acetic acid and hydrogen that is produced will be converted into methane and carbon dioxide. This phase shows the end of anaerobic degradation phase. Once methane and carbon dioxide is produced, the last stage again the aerobic process starts. Here, this is the last phase of waste degradation in a landfill, which is the oxidation process. Here, the partially degraded material are subjected to oxygen or oxidation, and as a result they are also broken down or mineralized to carbon dioxide. So, within a waste landfill, the degradation occurs in 5 different stages, starting from your hydrolysis or aerobic degradation to anaerobic degradation, where stage 2, 3 and 4 occurs, and finally stage 5 occurs at the end of anaerobic degradation, which is the oxidation stage. So, when your waste gets degraded or decomposed, it results in the production of methane, carbon dioxide and trace levels of hydrogen. Now, the factors as such, if you see, there are many factors which influence the waste degradation within your landfill, like your temperature, pH, the level of population of microorganisms and so on. So, for all these stages to occur properly, you should have proper pH. For example, if you talk about the methanogenic bacteria, the pH should be around 8, 7.8 to 8.5. If the pH goes below this, then the methanogenic bacteria will not be there and methane production will not occur. Likewise, the pH under acidogenic phase or during the production of organic acids, the pH drops even below 3.5 or 4. This is again important for the growth of acetoclastic bacteria. So, pH overall plays an important role. In addition to this, temperature again for the growth of bacteria, optimum temperature is required. Without an optimum temperature, again the bacterial or any microbial growth will not be proper. So, optimum temperature is very essential. Again, oxygen. In the initial stage, stage 1 and stage 5, oxygen is one important essential factor for the mineralization or breakdown of waste. Unlike your anaerobic phase, where oxygen requirement should not be there, or it should be very less for the existence of your anaerobic bacteria. So, these are some of the factors which influence the waste degradation within a landfill. Now, once the landfill is closed, by sealing it with a landfill cover, it is not sufficient that you forget about the landfill. You have to do certain post closure monitoring at least for a period of 5 to 10 years. Now, this post closure monitoring is done by analyzing your leachate monitoring or gas monitoring. Now, throughout your landfill, you should install, while construction itself, you should install a lot many groundwater wells. These wells should be sealed, and every fortnight or monthly you have to collect the water from these groundwater wells and then analyze them to check the water quality analysis. So, before constructing a landfill, you have a reference data of water quality analysis, and after you can measure and compare the water quality with the reference, and you can see whether there is any leakage or breakage or rupture in your liner material, and the leachate is entering into the or contaminating your groundwater or not, that you can find it out. Then the gas monitoring, again you should have gas monitoring station to find out if there is any excess leakage of gas from the landfill cover. To summarize, at the end of this module, we have discussed about the landfill structure and its components. Then we discussed about the different types of liner materials that are used in designing a liner system. Then we discussed about 3 different liner systems, that is your single liner system, your composite liner system and your double liner system. Then we discussed about the different types of waste emplacement, like your area method, trench method and cell method. Finally, we also discussed about the different layers that form a landfill cover and why a landfill cover is essential in a landfill system. Then we discussed about what are the different process or how waste degradation takes place within the landfill. We also discussed about certain factors that influence waste degradation within the landfill, and finally we discussed about the monitoring, post closure monitoring of landfill. I hope you would have enjoyed this module. Thank you.